Hey everyone, what's up Edmonton? Welcome to today's edition of your Edmonton Electrician. This is where we bring customer service back to the trades. So in today's edition of your Edmonton Electrician, we're going to be talking about three-phase power. As always here at Hauer Power Electrical, we are happy to answer our customers' questions, concerns. If you have an electrical concern or electrical topic, maybe an electrical issue that you want to hear about, we want to hear about that. We want to give you the most information that we possibly can. That's just another part of our customer service, what we do, and that's why we make these videos, to try and help you guys out. So as your professional Edmonton electrician, our mission is to provide you with exceptional power, and we do this through customer service, and we do this through these videos. So today we want to talk about three-phase power and single-phase power, two-phase power, which that's not really fully correct. If you want to call it two-phase, sure, but you should know what it's really called, because it's not actually two-phase. So yeah, we'll get into three-phase power, where to use three-phase power, typically commercial sites, industrial sites. If you're a commercial facilities maintenance guy, you have probably seen three-phase power in your building, but maybe you don't know exactly what to do. That's where we come in as a quality electrical contractor, and we show you what's going on with your system and what we can do with it, what you need to do with it, things to make it more effective, more efficient. A lot of questions we get are why not more phases, 4, 5, 6 phase power, 12 phase power. We'll get into that, why that's not really a thing. And then we'll kind of touch on the brief construction of a alternating current generator. That might help you understand more about three-phase power and single-phase power. And then, yeah, what exactly Hertz really is. We've touched on that before in another video, but we'll touch on it again. So we'll get right into it. So single-phase power, that's what you're going to find in a residential application. So all of our residential electricians deal with single-phase power every single day. Really, single-phase goes on and off so fast that the human eye cannot see it. So single phase is great for lights, plugs, just about any device you'll find in your house, even your microwave, your blender, your washer, dryer, stove. It works great for all those things. It's less efficient for motors, and that's why you'll get a higher current value on a single phase motor than maybe a three-phase motor. So that's going to come back to watts, and that's how your power is measured by the utility company. But regardless, three-phase power isn't really effective in a home. It's not cost effective, because you need more wires and more copper, and that means more money. So for a commercial application or an industrial application, that's where three-phase is really going to come into effect more, especially if you have a pump that needs to move water. Well, yeah, you can get a 120 volt pump, but it's not going to move near as much water as a three-phase pump. You just, if you need that, if it's going to be making you money, you need to move as much water as possible. So that's why you're going to need three-phase power for that. Same goes for a motor, right? You can have a single-phase motor. Look at your bedroom fan. Look at your fart fan in your bathroom, right? If you have a bathroom ventilation fan, that's operating on 120 volt. That's not 240 volt, and it's working just fine. But if you're in an industrial situation, or maybe you're running a paint shop, you have an automotive shop, your electrician at your automotive shop or your car dealership or something like that, if he were to run $120 fans, you wouldn't get the suction that you need to really suck those fumes out of there. That's why sometimes you want to have three-phase power to those. The higher voltage, the more phases, that's going to give you a better power situation for if you have large pumps and motors. Also, lighting, you might encounter 347, 600 volt lighting, and that's going to allow you to have a whole lot more lights on a circuit than a typical single phase circuit. So a single phase 120 volt, that's great, but you're only going to get so much out of it. So at the end of the day, you want three phase for large loads. That's I guess what we get down to it. The larger the load, maybe you want three phase. So on a grand scale, people say, oh, why not more phases? 4 phase, 5 phase, 6 phase. No, you're not going to have any of that. It's costly, and it's not widely accepted, unlike three phase. The benefits of more phases are they're inefficient and moot. It's not applicable really. So if you were to have three phase power, each one of those phases operates 120 degrees out of sync with each of themselves. So Your first phase, it's going to peak up and it's going to peak down on a sine wave. So that sine wave simply reflects the speed of electrons that's alternating backwards and forwards. So as the speed of electrons alternates backwards and forwards, plotting this on a graph gives you a sine wave pattern. Backwards and forwards meaning up to the top of your sine wave and down to the bottom of your sine wave. Sine wave's just going to go up and down and up and down, and it's going to repeat. So if you have one single phase, then when you're up, you're at your peak, and when you're down, you're at your bottom peak. And that's where you're actually getting your power. That's what's giving you your light on. So it alternates so fast that the human eye can't see it. So when you have single phase electrical power, your light is seeing that power go all the way up, and it's seeing it at all the way down, but the rest of the time it's not really on, right? So that's why you're seeing it on all the time, because your eye just can't register that it's actually flickering. If you were to go to, or dimming I should say, not flickering, if you were to go to a super slow motion camera, super slow motion, that would be able to pick it up, and you would see that the light is in fact not on 100% of the time to the full amount that it appears on. So again, while we're on the single phase topic, we'll get to two phase and why that's incorrect. So it's not actually two phase, it's a single phase. And when you are saying two phase, we're imagining you're assuming 120 volts difference to ground on one line, incoming line to your home, and 120 volt difference to ground on the second line coming to your home, because you have two lines coming to your home and one neutral. So you have those two lines coming in, and that's going to power up not necessarily the left side of your panel and not necessarily the right side of your panel, but it's going to stagger. So line 1 is going to cover your two top breakers. Line 2 is going to cover the next two breakers, and so forth. That way you can plug on any 240 volt breaker. So when you say it's a 240 volt stove or a 240 volt dryer, or even if you say 220 volt, essentially it's 240 volts if you put a meter on it here in Canada, here in Edmonton. So as your Edmonton electrician, when we put a meter on it, we'll show you it's 240 volt. It's not 220 or 225 volt or anything like that. That's just manufacturer spec wherever it's coming from, if it's coming from Europe or China or the States or wherever it's coming from. But here in Edmonton, it's 240 volt in your home. Again, it's not two phase, we call it split phase. So it's still single phase power. 240 volt is still single phase power. It's just split phase, because when you have your transformer out on the bucket, whether you have an overhead service, pole mounted transformer, or you have an underground service and the transformer's out in a box out on the street, regardless, that transformer is going to have their main primary lines coming in off of their utility three-phase power. So that's going to come in and then branch off on one of those phases. You're going to get one of those phases branching off to your transformer, and possibly to all your neighbors as well. And that phase is going to go to a coil, which is going to step it down to 120, 240 volt that you see at your house. Now, that coil is going to have on one side of the coil one line coming to your meter, coming to your panel, coming to your line at your overcurrent device, and another line coming off the other side of that coil. So your coil is just a strand of wire essentially off that transformer. So you're going to have 120 volt coming on one side, 120 volt coming on the other side, and your neutral is going to be right in the middle. So that's why we call it split phase, is because you're getting 120 volt difference to ground from one line to the neutral, and then on your other line to neutral, you're getting another 120 volt difference to ground. And in that neutral line, when you get your 240 volt, you're actually getting the full range of that coil for your stove or your dryer or whatever other 240 volt load you have in your house, maybe a hot tub, maybe an AC unit, welder, whatever you have going on. But regardless, that's why it's not called two phase, it's called split phase. And again, why not more phases, 4, 5, 6, etc. So yes, costly, not widely accepted, but when you have three-phase power and each phase is 120 degrees out of sync, you're going to have a small gap in between the tops and bottoms of those three phases where they're not where there's going to be a gap. So if you added 3 more phases to fill those gaps, you're effectively not filling the gap. You're just creating a smaller gap. But you'd have to run 3 more wires and have 3 more coils, and that's just going to get that much more costly. So again, if you were to add 3 phases every single time to not fill those gaps but make those gaps smaller, it's effectively a half-life situation, just like how radiation dies. You're never going to completely remove it. However, you will make it smaller and smaller, but the amount of efficiency you would gain from filling up those small gaps with more phases, more coils, and more cable, that's not going to prove more efficient than your typical 3-phase system. So that's why we operate strictly on a 3-phase system. In Teslas, Tesla experimented with 2-phase and with other amounts of phases, but the most widely accepted, the most widely used, and the most efficient systems are a 1-phase and a 3-phase. So a 3-phase is going to come from your utility company. It's going to go to a step-up transformer and shoot it across the neighborhoods, the commercial sites, etc. And then it's going to branch off 1-phase for smaller areas, and then it's going to step it down further at another transformer for your home to work at a safe voltage, because you're not going to have 13.6 or 13.5 kV, whatever the right value is. You're not going to have that coming into your home, because that just would not be safe. So that's why you don't have more phases. That's why 2-phase is not essentially a thing, because it's not 2 phases, it's really just 1 phase. And that's why 3-phase is the most efficient way to have high amounts of power current for your motors, your pumps, etc., your lighting, whatever loads you may have in a commercial facility. So you'll see 3-phase more often in industrial facilities. You'll see it plenty there, but as your commercial Edmonton electrician, we see it often for motors and pumps. Doing a lot of laboratory work here in Edmonton, we do a lot of electrical for laboratories, and the motors, pumps, equipment, lighting that they use is often 3-phase, 347 volt, 600 volt. That's how that one works there. So you got to deal with a lot more hazard, a lot more shock when you deal with 3-phase electrical, but at the end of the day, it might be the right setup for your system. So as always, remember when you're working with electrical power, the hazards that come with it. So injury, shock, death, property damage, those are all very valid hazards. They're all very relevant to the trade. So if you are not qualified, if you're not competent or confident in doing electrical work, you should call your local electrician. Call Hauer Power Electrical. We are your Edmonton electrician. We serve all of Edmonton and surrounding area. We're happy to provide free estimates for all of our customers, new, old, existing. If you think maybe we missed something in this video here and you say, hey, actually, what about this? Well, yeah, it's a wide topic. Search our page at hauerpower.ca or search our YouTube channel and see maybe if we already made a video, because if not, we'd love to hear about it, and we'd love to make a new video and clear up any questions, concerns, or electrical issues, electrical topics that you might have and you might want discussed. So again, just to kind of summarize it all, your speed of electrons, that's going to alternate backwards and forwards, and if you plot that on a graph, it's going to be what's known as a sine wave pattern. Those speed of electrons, they're cycling at 50 to 60 cycles per second. That's what's provided at your power station, and that's what's referred to as your frequency of power, right? That's your hertz. Here in Edmonton, our electricians only see 60 hertz. You might see 50 hertz in other places. You can put a 50 hertz piece of equipment on 60 hertz systems, but you cannot put a 60 hertz system on a piece of equipment, on a 50 hertz system. It just won't work. It'll burn out. It'll die faster. So as always, here as your Edmonton electrician, our mission is to provide you with exceptional power, and we do that through customer service. And one more way that we like to reach out to our customers is through these YouTube videos. So if you like it, like the video, subscribe to the video. We make new videos all the time. And if you have any questions, feel free to reach out to us. 780-935-0622. That's how you can reach us directly, or email us at info@hauerpower.ca. So as always, here as your Edmonton electrician, we look forward to giving you power, and I hope we hear from you soon. Have a great day, guys. Take care. Bye.